Hello, my friends. Welcome back to our channel. Today we discuss the second task of the first round of the 2022 Federal Mathematics Competition in Germany. We plot the three altitudes of an equilateral triangle. Then, we add a new equilateral triangle in each step in the following process. In the first step, we plot the new equilateral triangle by connecting the midpoints of the three sides. In the second step, we connect the midpoints of the three sides of the new equilateral triangle of the first step. And so on. After which step, the number of all triangles will be more than 2022? Why not give a try, and we will come back soon. This task is not difficult, and the key point is to count the triangles according to certain rules, neither repeating nor falling. We are following two lines here. The first line is certainly regarding the steps. Let's first look at how many triangles there are in the initial figure, and then count how many new triangles are added at each step. The second line is about how to count the number of triangles in each step. The two easiest ways are either going from small to large ones, or the other way around. Here, we use the first way, that is, from small to large. Let's take a look at the most basic unit first, that is, the triangles which are no longer divided by any line segments within each one. There are 6 such triangles in total. Then we look at the larger triangle made up of 2 of these basic units, and 3 in total. Next is the larger triangle consisting of 3 basic units, and there are 6. There is no way to form a large triangle from 4 or 5 basic units. The next one is a large triangle composed of 6 basic units, and of course there is only 1. So there are a total of 16 triangles in the initial figure. Now let's look at the first step. At this time, the original 16 triangles are still there. And all new triangles that are generated in this step must have at least one side that falls on the sides of the newly added equilateral triangle. If we only pay our attentions to the inside of this newly added equilateral triangle in itself, we will find that it is not different from the original figure, only except for the size and direction. So inside this newly added equilateral triangle, well, also including itself, the number of triangles must be also 16. Of course, this doesn't end there. Because outside this equilateral triangle, new triangles are also generated. For example, triangles like this. There are 6 in total. This type. It seems there are 4, but don't forget that the middle one is already included in the 16 newly generated triangles just discussed. So please don't repeat it, and in fact there are 3 of this type. In addition, this type is also newly generated. And they are also 6. So a total of 31 new triangles are generated. Next we look at the second step. The 16 and 31 triangles we just discussed are still there. After adding the new equilateral triangle, we will find that its relationship with the equilateral triangle added in the first step is the same as the relationship between the equilateral triangle added in the first step and the original equilateral triangle. That is to say, according to the relationship between these two equilateral triangles, 31 new triangles must have been generated. In addition, any part of the newly added equilateral triangle in the second step cannot form a new triangle with any part of the original equilateral triangle. This is very important. And its significance is that each new equilateral triangle in the next step will not generate more triangles by intersecting with equilateral triangles earlier than the previous step. Then at each step, the number of newly generated triangles is always 31. So, we plot the equilateral triangles step by step. Till the nth step, the total number of triangles obtained is 16 plus 31 times n. If it is bigger than 2022, n is bigger than 64.7. So the answer is that, after the 65th step, the total number of triangles becomes bigger 2022. Thank you for watching, and see you tomorrow.